a little bit exciting. Got the up counter that's able to count up now. Let me just turn the lights off. Just touch this wire on this capacitor here repeatedly. And there you have it. These LEDs underneath, it's the binary representation of the number there. Alright, let me give you a rundown on what's going down here. Basically, I've got a up-down counter chip. Up-down counter. And I've also got a BCD to 7 segment decoder. So BCD is binary coded decimal, and we decode that into 7 segments. But before we get to the 7 segments, basically I feed that into an array of transistors. So we've got basically 7 lines coming to there, 1, 2, 3, 4, 5, 6, 7, something like that. This is a transistor array. Okay, and then on the other side, we've got resistors, and so on, which goes to the display. Remember, that's A, B, C, D, E, F, and G. Now, the up-down counter is 4 lines, binary. So if you're familiar with binary, all good. If you're not, this is how it works basically. So this is a number for us as humans here: 0, 1, 2, 3, 4, 5, 6, 7, etc. Okay. And the binary representation, I can't do this on the top of my head for each number, but what I can do is go 0, 1, 0, 1, 0, 1, 0, 1, and then double up on that: 0, 0, 1, 1, 0, 0, 1, 1, and then again double up on that: 0, 0, 0, 0, 1, 1, 1, 1, and then again 0, 0, 0, 0, 0, 0, 0, 0, etc., etc. So that's only a 4 binary bits there. So basically this chip here, I've got this configured to count upwards, and basically it's counting like this: 0, 1, 2. We don't see this, we just see the chip just spits out these codes here, and the one just resembles a high voltage or no voltage, a high voltage or no voltage. So high, high, low, 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 high, low. And that's what this thing is spitting out here as it's counting. Now I'm coming in here and touching a bit of wire through just putting in a signal, which is basically called a clock. So I just put a high and then a low, a high and then a low. You saw me touching the wire, that's what I'm doing there, which basically clocks this counter. I've configured it to count up. There's a connection on this chip. You basically just tie it up to plus volts to count up, or you tie it down to 0 volts to count down, and then you clock it, and this will start counting up. Now, for us humans, looking at a bunch of voltages is not great. Looking at a bunch of LEDs is better, but even better than that, if we can see the decimal equivalent to this binary number, great. And that's what this chip does. It will decode this binary number to a number us humans can understand. So that decodes it, and then this goes into a transistor array. I just had a look online just a few minutes ago. Right now they're priced locally in a store here, they're priced at something like, you know, $5 whatever each. I could have used individual transistors. I don't know if you can see it in the shot here. Oh. Anyway, there's a transistor here which I've used for the LEDs. It's cheaper to go that way but consumes more space. This is faster, getting the array, which is a chip that's there. Much easier to wire up, etc, etc, but it's going to cost you $5 for one of those. So that's what we've got. Basically that gets repeated for the next significant digit, and so on and so on. What I've got to do now is my next task is to read this data sheet here and figure out what I've got to do to spit out a signal from this counter off to the other binary coded decimal decoder / counter, etc., and then just replicate that. Well, we need to do that 3 more times. Remember, this is going to count to 9,999. Probably never get that high, but we'll allow for it. And yeah, so I've got a diagram. This is like a 2-month-old diagram. I've made some changes here. What I need to do now is do some tests and from the data sheet work out what I got to do. You know, when you read these data sheets, I don't care how long you've been doing electronics or how much of an expert you are. You know, it comes down to how well are you able to interpret all this stuff here. And trust me, I work with many electronic technicians in the past, and even they get things wrong. So what I'm saying is I don't want to just commit and rewire each of these counters, and wire each of these counters without knowing for sure that what I do on the least significant digit to the most significant digit, make sure I get that right, and then I can just go through and then do the rest. Remember, this is going to get replicated down here again. So I'll be doing some tests, and hopefully the next time you see me, we'll have this thing counting all the way up to 9,999. So that's it for now. I'm happy that's going. You know, when you spend hours and hours doing all this and you finally see something happen, it's quite exciting. Right, till next time, like, comment, subscribe, whatever. Thank you.